Hello and welcome back to the channel. Today we are going to discuss about real numbers and questions related to them for class 10th. So let's get started. So before moving ahead with question number 1, we should look at the racialized syllabus given by CBSE. So some of the portion has been deleted by CBSE. That is from real numbers, it is Euclid's division lemma and revisiting rational numbers and the decimal expansions. So apart from that, whatever is being there is being given to us in the chapter. We will discuss questions based on that. Question number 1. HCF and LCM of two numbers. So two numbers are given to us. One of HCF and LCM is given to us. One of the number is given to us. And we have to find out what other number. So we know that this is based on the concept of product of two numbers is equal to what? Product of their LCM and HCFs, right? So product of two numbers. We know one number. We don't know another number. Let's say x. LCM is given to us. LCM is given to us, which is 459. HCF is given to us, which is 9. So x becomes, you know how to solve it, right? Just cancel it down and you will get the answer. So 9 3s are 27, 3 1s are 3, 3 5s are 15, 3 3s are 9. So the number is 153, right? Let's move on to next question. Here find LCM of numbers whose prime factorization are this. What we are supposed to find out LCM. Before that, before going ahead with the solution, you should know what is LCM, what is HCF. I'm pretty sure that you know that, let's say if I have to find out LCM of 6 and 15, so I'll simply factorize it. 2 3s are 6, 3 5s are 15, 5 1s are 5. So we say that whichever is the common thing, we count that one time and rest of the elements has to be taken. So this is the LCM, correct? That is 30. 3 2s are 6, 5s are 30. Whereas HCF is whichever number is common, that is 3 here. So you can see what we take when it comes to LCM is the product of highest powers of factors, correct? For example, this is 2 into 3, this is 3 into 5. We have all the powers as 1. So in LCM what we did, the highest power, so this is 3 raised to power 1. Highest only consider one time, so 3 raised to power 1 has been considered one time and then 2 into 5. Whereas product is what? HCF is what? Product of lowest power of factors. So amongst these, and that too should be common, so we will take this one as common and one time power is considered. So why I'm telling you all this? Because now number is not given to us, the prime factorization is given to us. So 1 is 3 into 5 square, 3 square into 7 square. One way of doing it is just simply multiply everything, right? If you split this, then what is common? 3 is common, so 3 will be considered as one time, and rest all the numbers will be considered 7 into 7, right? And you can simply get the answer by multiplying these, correct? Also remember, this has been considered one time. This is HCF, but LCM is the highest power. So this 3 cannot be ignored, correct? So just simply multiply. 3 3s are 9, 5s are 45, 7 5s are 35, 5 5s are 25, 5 4s are 20, 22, 5 3s are 15, 4 3s are 12, 13, 5 7 5 1, 5 7 5 into 7, 7 7s are 49, 52, 7 5 35, 40, 7 is 7, 11025 is the answer. But if we go with this concept, it will be the product of highest powers. So you can see between these two, 3 and 3 square, highest power is 3 square. So we will consider that. Then all the rest, 5 square, 7 square. So this will be the answer, which will take you to this, and 1125 will be the answer. Are you getting the concept? Though this question was pretty simple and you could have done applying those prime factorization, getting the number and taking out common one time. But still I wanted to tell you this concept, which you might not know. Let's begin with another question. So question is, find the largest number which divides 70 and 125, leaving remainder 5 and 8. We need largest number, and that too when will be divided, when divides these numbers, 5 is the remainder when divides 70 and 8 is the remainder when divides 125. So that means if I subtract, if I take away these remainders, that largest number absolutely divide whatever is the answer, correct? That is 65 and 117. 15 minus 8, 7. Yes. So that means now that largest number can divide 65 and 117 fully, correct? So now how can we find out largest number? It is pretty simple that largest number will be HCF. So you can find the HCF, you know how to do it. It's just a matter of the language which is given in the question, and to find out whether LCM is there. LCM is least common multiple, right? And this is highest. So largest, for largest we are considering HCF. Take the LCM, 5 ones are 5, 5 3s are 15, and 13 ones are 13. This is 13, 9s are 117, 3 3s are 9, 3 ones are 3. So we can see that largest number which can divide both of them, that is 13. Next. This is very important. It almost comes in every year, every single year in board examination, that you have to prove root 5 as irrational. Then I have clubbed two questions together that then show that 2 plus 3 root 5 is an irrational. So let's focus on root 5 first. Whenever such sort of question comes, it goes in the principle, or you can solve it with the principle of contradiction, where whatever question is asking us to prove, we always consider opposite of that. So question is asking root 5 is irrational. Let's consider that, let us assume that root 5 is rational. Okay, we have considered opposite of that. Now you know what do we mean by rational numbers. If I ask you define rational numbers, what will you say? That those numbers which are in the form of p by q, where the denominator should not be equals to 0, and p and q should be integers, correct? Also, one condition is p and q are co-prime numbers, correct? What do we mean by co-prime? When p and q do not have anything common except 1, then HCF should be 1. That means, let's say if I say 9 by 4, so you can see in between 9 and 4 there is nothing common. But when I say 2 by 4, you can't say that 2 by 4 is rational, because 2 and 4 are not co-prime. They have something common. They have a common factor. So firstly simplify them, then you will say that 1 by 2 is rational. Anyways, this was additional thing. Let's come back to question. So I have assumed that root 5 is rational. So that means these conditions need to be fulfilled. Correct? So I am saying that, okay, root 5 is rational, so it will be in the form of p by q, where q is not equals to 0, p and q are integers, and all those things. Now, can I take q to left hand side and, this form can be made. And then squaring both sides, so it will give you 5q square equal p. Correct? Now you can see if you take this 5 to right hand side, this will give you p by 5. That means 5 divides p. Correct? 5 divides p. Let's assume this is first equation. Okay? Now if 5 divides p, that means p by 5. Can I assume that whatever p is, it will give you the coefficient as c, some random number, where c is an integer, any random integer, because p can be anything, so which can be divided by 5. So I have assumed c is the answer. So this will give you 5c. If you squaring both sides now, it will give you 5 p square. 5 5 is 25 c square. This is second. Now you have here p square should be there, right? If you squaring both sides, p square should come. 5 divides p square. Correct? If 5 divides p square, this means 5 should also divide p. If 5 divides p, I have assumed this as a condition. Then again I am squaring both sides. Now from first and second, see this one and this one. Can I say from first and second that p square is common? So 5q square becomes 25c square. Then 5 is cancelled out. Q square becomes 5c square. Correct? Again, this has taken this form. So I can say that 5 divides q square. Correct? This means 5 divides q square. If 5 divides q square, that means 5 divides q as well. But what? 5 divides both p and q. If 5 divides both p and q and is the common factor between p and q, that means p and q are not co-prime. If they are not co-prime, then our assumption was wrong. Because this contradicts our assumption, right? That means root 5 is not rational, which we assumed. It is instead irrational. Does this make sense? So what I'm writing, this implies 5 is the common factor because it is dividing both p and q of p and q. So p and q are not co-prime. And if they are not co-prime, that means root 5 is irrational. Clear? This is how you proved it. You prove it. Now, once it is done, then you can take the help of this answer to solve this. 2 plus 3 root 5. Let's say how. Let's see how. 2 plus 3 root 5, right? So now I have to assume 2 plus root 5. Let's assume 2 plus root 5 is irrational. We have to prove irrational, so we are assuming in contradiction that it is rational. Again that same theory, if we have assumed it rational, so that means 2 plus root 5 should be in the form of p by q, where q should not be 0, p and q are integers and p and q are co-prime numbers. Correct? So we can say co-prime integers. Exact. Okay, if it is the case, so root 5 will be p by q minus 2, right? So root 5 will be p minus 2q by q. I've taken LCM, cross multiply. P minus 2q by q. But what is this form? this is in the form of P by Q, right? We can see right hand side is rational, whereas left hand side we just proved it that root 5 we can say, but root 5 is irrational. Can you have such values where one equal thing is not equal to other? So it is irrational, this form is rational, and both of them are equal? What a joke. So that means they simply say that this contradicts our assumption. We have considered something wrong. And that simply brings us to the answer, which means 2 plus root 5 is irrational. Okay? I'm hoping that this part is clear to you. So this is very shorter than what we proved in root 5. So root 5 comes in high weightage question and this comes in lesser. Let's move on to next question. You have to prove, you have to state the reason why this thing, this expansion is a composite number. Before going ahead, you should know what is the keyword of the question, why and composite number. And then you have to relate them, that define why do you can see this composite. So what is a composite number? Composite number means opposite of prime. That means having more than two prime factors. For example, if I say 17, it is 17 into 1. We have only two prime factors, 17 and 1. Though one cannot be considered prime or composite, but we have only these two factors. So that means it is prime. But when I say 4, I can split it into 2, into 1, into 4. So we can see that it has more than two factors. So that means it is a composite. So let's form this into a form where we can say it has more than two factors. We have 17 into 5 into 11 into 3 into 2 plus 2 into 11. You know that you can only take common out when numbers are separated with the operation of addition and subtraction. You cannot take common from multiplication, right? So this is one term and this is another. What is common? 2 is here, 2 is here, yes. 11 is here, 11 is here. So I can take out common as 2 into 11, correct? What is left? 17, 5, 3 from first term and 1 from the last term, correct? So 2 into 11 is 22. Then you have 17, or just simply not write it in the, collapsed form. Just keep it 2 into 11. Now what is this? 17 5s are 85, 3s are 35. So 255 plus 1, that is 256. So we can clearly see you can also split 256 into factors. But that is definitely going to be more than two prime factors because it has more than, this expansion has more than two prime factors. So we will say yes, this expansion is a composite number. Clear? This is how you prove it. You have to see how many marks question is given to us, how many marks has been allotted to a particular question. So if it is of 1 mark, you can simply write the expansion and say yes. If it is of more than 1 mark, you have to explain the process because methods has also got scores. Next, can two numbers have 15 as their HCF and 175 as their LCM? So this question I found unique in previous year question papers. That's why I put it into this slide. Basically, question is asking us that we know product of two numbers is product of LCM and HCF, right? Product of two numbers is LCM and HCF. But two numbers are not given to us. It is simply saying, can we have 15 as HCF and 175 as LCM without knowing that what are the numbers? So I would say, I will explain you with the example. Let's say we have 6 and 15 here. 2 3s are 6, 3 1s are 3. I gave you the same example before as well. 3 5s are 15, 5 is a 5. So we can see HCF is what? This common 3, highest common factor. And LCM is what? What can you consider LCM? 2 into 3 into 5, correct? So you can say that HCF, you have LCM, a broader term, which is some multiple of HCF, correct? 3 as HCF is coming in the expansion of LCM. So I am saying that yes, LCM is the multiple of HCF. Of course, we can find out with the help of example, right? So I am assuming that multiple be X or K, whatever. Now, this K multiple should be an integer, not in decimal form. Find out the value of K. If it comes out as negative, I mean, a negative cannot come, but if it comes out as in decimals, you cannot consider that those LCM and HCF would work. Okay? So, what is LCM given to us? 175. What is HCF? 15. So, K will be 175 by 15. 5 3s are 15, 5 5s are 25, 3 1s are 3, 3 1s are 3, and then 3 6 are 18, and so on. So you can see that K is not a whole number. K is not a whole number. It is in decimal form. So we can say that no, this LCM, this HCF and this LCM is not possible. No, those numbers cannot have 15 and 175 as their HCF and LCM respectively. I'm hoping that this makes sense. So this is it for today. I hope that you've enjoyed the session. If so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself and keep trying for board examination. Just search with, find out mock test papers, search with the keywords. Topic wise topic, you should have ample of questions and practice that. It would work. All the best. Bye.